Hello everyone, how are you all doing? This is a special session on Git and GitHub and even Git Pages or GitHub Pages where you can host your own website. If you have gone through any of the Azure labs like AZ 900 lab or AZ 104 lab, you may have noticed that all these are hosted in GitHub Pages, not on the regular GitHub. And as an exercise, I encourage all of you to prepare a resume and host it in your GitHub Pages site. I have created one and I will share with you during the class. So let us get started without any delays. Git 101 getting started with the source code management with the Git, GitHub, and GitHub Pages. Announcements. For the labs, you can head to your respective Zoom groups. So if you are part of C1, you will have a Zoom group of your own. If you are part of C2, you will have a 24/7 Zoom of your own. Other groups will not have a Zoom group because they are free groups. So they can discuss within their respective groups. So you can do your labs on your own and discuss any doubts within the group as chat. And people from S1 and S2 will not have permission to post anything, but they can freely move to either F1 or F2. From there, they can make contributions in the form of taking just one session a month, or they can pay a small fee to help the community manage its expenses and then become part of C1 or C2 group. All the expenses of C1 and C2 are managed by the group itself, and nothing is being taken out by anybody, including me. What is the agenda for today? First of all, what is source control? The type of source control systems, centralized versus distributed systems. What are these Git, Git Bash, GitHub, GitLab, Bitbucket? I'm sure if you are in software industry, you may have heard at least some of these things at some point of time in your career. And we will discuss some of the important Git concepts and commands with hands-on examples. And then we have a getting started section for GitHub Pages to create your own portfolio or blog with, again, hands-on examples. Finally, peek into advanced Git concepts and our future session plans. And we will conclude with some of the Git best practices. So if you are new to my sessions and if you do not know me, I am Hartin Kaniguthotu. And this is my GitHub Pages based resume, hartin.github.io, which you can also create based on the topics discussed in this particular session. I have written a few books on cloud computing, and it is available through all popular platforms, including Pact, Amazon, O'Reilly. And one of these books has got this award of best 8th cloud computing book of all time in 2020. I've taken quite a lot of certifications, including Azure Solutions Architect, DevOps Engineer Expert, and I'm also a Microsoft certified trainer. What is this source control or version control? Can you mention in the chat if you have used any kind of source control or version control systems till now? Yes or no? And if you are using any kind of source control systems or have used, just mention those names also in the chat. Source control or version control or revision control or source code management, different people may call these systems in different ways. They're a system that manages changes to computer programs, documents, large websites, or other collections of information. Developers will use these systems to store their code. What are the advantages of storing these in repositories? One advantage is that These repositories are generally kept in a remote place, and there will definitely be a backup management and all in that remote place. So even if your system crashes, your code, your precious code that you wrote will be always safe there with that repository. In most cases, as a developer or as a DevOps engineer, you will not be working alone, right? This source control or version control systems will allow you to share your code with others. So once you put your code into a common source control repository, others can look into it for various reasons. Sometimes just for knowledge purposes, sometimes to review your code. So if I am managing a repository and you are putting some code into my repository, I can review and see, okay, whether the code is correct, whether the code is following certain guidelines. And I can also have automated tests to make sure things are fine before merging your code with my repository code. Okay, version control is a component of software configuration management. So software configuration management is the task of tracking and controlling changes in the software, part of configuration management. A source control system allows development teams to collaborate on code and track changes. Developers use source control as a repository for source code and configuration files, etc., etc. So is it only for developers? No. So infrastructure teams also use it for infrastructure provisioning scripts. Source control management systems provide a running history of code development and resolve conflicts when merging contributions from multiple sources. Imagine that I have a set of code that is having A, B, C, D, E. Myself and another developer take this code into or copy of code into their own systems, and I say I change D with F, and another developer changes D with H. When it gets merged, usually there will be a conflict. You will have to choose whether you need to go with this change or that change. And sometimes you will have to take a decision through a manual step, and then you will have to continue merging the code. So merging the code means applying your changes into the main repository. The code and history of code is stored in this source code management or source control management repository. A project can have multiple repositories. You can have different repositories representing different microservices. And source control is a critical part of also DevOps. It is not just for developers, it is for everybody. In fact, everybody in the software industry. So some of the benefits of source control: you can create automated workflows. You can work with different versions of the code. How many of you have watched this TV series called Loki, or watched these movies that talk about multiverse and all? Working with various different versions and parts and all those things can also lead to madness at times. That is why a proper understanding of Git is always going to be helpful for you. Okay, and then another benefit, as I mentioned, you can collaborate with other developers. You can maintain history of changes. You can automate tasks such as whenever somebody merged code into my repository, I can run some tests, and if tests are fine, I can say that okay, the new code, package it, and then deploy it onto a server. There are two types of source control systems in general: centralized source control and distributed source control. So when I started my career a very long time as a normal developer in IT, I used to use centralized source control systems. Especially the one I was using was Subversion or SVN. There are other ones like Perforce, TFVC, CVS, etc. So here, there is a single central copy of your project, and programmers commit their changes to this central copy. So what were the strengths? So easily scales for a very large code bases because code is only there in one central copy. You can have a granular permission control. It used to allow exclusive file locking and similar things. Was used for scenarios such as large integrated code bases, audit and access control down to file level, hard to merge file types. These days, with distributed source control, also you have workarounds for most of these things. Then comes distributed source control, which is kind of very popular these days. Every developer clones a copy of the repository and has full history of the project. So with the centralized, the whole history is only part of one central place or one central repository. But here, every developer clone a copy of that whole thing into your system. So you have the whole or full history of things similar to what you have with centralized in your central server. With central server, all history is only there in one central server. So here, all history is part of your clone. And from the clone, you do similar operations that you do from the central repository. Check out a project, you work on that project, or you create a branch of the project. We'll talk about these terms soon. You do similar operations, but all history is there in your local machine. And hence, it is called a distributed source control. You may be thinking, if it is a copy, then how do I share this with other people? So here also, you will have a copy on server, which is generally referred to as your remote. So this remote copy will be in sync with your local copy. And from that remote copy, other people can also create clones and then work. Okay, and common distributed source control systems are Mercurial, Git, and Bazaar. And out of it, Git is definitely the most popular one, and the one we are going to focus in our session as well as in future sessions. Strengths, it has a very good cross-platform support, an open source friendly code review model via pull requests. So what are these pull requests? I told, right, other people will be merging code, and then you can raise something called as pull request so that before actually merging that code, other people can review your code. Okay, what do you mean by review? So whether it is following the right model, whether it is correct, automated tests and all, generally checks for only the working of the code, but not with respect to best practices or certain things that cannot be covered through these tests. So in general, a senior person or even all the team members will be reviewing your code before getting merged to the main repository. You have complete offline support. You can work completely in your laptop, and then later when you decide, you can sync it with the main repository. But as a general practice, people do sync with the general repository or the remote repository very frequently to avoid the conflicts with other developers working on the same project. You have a portable history. So the whole history is part of your local machine. Enthusiastic growing user base is also there for distributed source control. It is best used for smaller size and modular code bases, evolving through open source, highly distributed teams, teams working across platforms, greenfield code bases. So in summary, in Central, you have one central server and a client at the user side. Using the client, we check out files, we make changes, and we commit them back. In distributed, every user has a copy or clone of the server with all history and all branches. What are these branches? You have a central code. Imagine that you are going to work on a feature. Let us take a real example. Currently, cloudrex.com do not have a automated enrollment process, and admins are actually trying their best to manually enroll people. And we decided to build a module or feature that will do automated enrollments. So I have to write new code. Then what will I do? I'll not simply write all the code that comes to my mind into the main one. I'll create a branch. Branch is something that runs parallelly in your server. or in case of Git, the branches will be a part of your local machine, and then you can sync it with your remote repository. So you'll create a branch, you will make all those changes there. You will be regularly updating your changes to the branch. And if you are syncing these branches to the central repository, then other people can also work on these branches, make changes to these branches without affecting the original code. And once all the code is tested in these branches, then you can merge this branch into the main branch. So there are different branching strategies that we will see later. There are a lot of things to discuss just around these branching strategies. But in summary, it is just creating a copy in the server itself or creating a copy in the clone itself and then making your changes there without affecting the main line. Checkout means you are getting the code from this branch, either the main branch or your feature branches into your work environment. And after checking out, what you will do, you will make changes to these files, and then you will do a process called as a commit. Commit means we are telling, okay, these changes are final, and then we will push these changes towards our server code. When we check in files, so these files will go into the branches, and then finally when you push, these will go into the server. Okay, do not worry about these terms. We will make things much more clearer when we go through some examples. In distributed, every user has a copy of the server with all history and branches. You generally start by creating a copy or clone of remote repository on a server to your local repository. From the local server, you can check out files, make changes, commit them back to the local server. Finally, you can push these changes to the remote repository. You can also pull changes from the remote repository anytime. For example, if someone else push their changes. So quick note on Git distributed source control system. Each developer has a copy of the source repository on their development system. Initial version was released on 7 April 2005. Original author was Linus Torvalds, and currently it is maintained by Junio Hamano and a few others. So few reasons why it is good to use Git. You can create feature branches easily. So I mentioned about the main line. Here the master is the main line here. These days, instead of master, people call it as a main. And then you have feature lines. For every feature, you can create a different line and then later merge that line into the main. And it is distributed. So the full repo is available everywhere. You can have pull requests before merging your branch code to main so that other people can review your code. It has a very good community support. So community is a very important thing for many projects. Even the success of our CloudRig's platform is just because of the community that supports it. And you can have various different release cycles based on your need. And there are also some best practices for those things that we will see as part of our branching strategies session. Okay, there is a question. Even in central repository, we get latest code and store in local repository. We push to server. The distributed repository also doing the same. Is it? In case of central repository, where do you check out code? From the server or from the local code? Local repository. Yes, from server, right? But in case of a distributed, you check out from your local server and not from remote server. You first take a copy of your server into your local machine, and from there you check out. In case of central, you check out directly from the remote server. Is it clear? Okay, but in that case, we might latest code from server miss the latest code. Yeah, so here you can do another set of operations called push and pull. In central repositories, you take your central code, you check out your central code, you make changes, and then you commit and then check-in and all those things in your central repository directly. But here, you take a copy of your code into your local repository. You have full freedom on what to do. And then after checking in your code to your local server through a commit, you do something called as push. When you push, you sync your local server code with the remote server code. And when you pull, you take the remote server code into your local server code. So as a good practice, as a best practice, you always do this on a regular basis. And with the other remote server approach, you have to be connected to the server to see what all other branches are there. So here, once you pull, that history is there in your local, and you can see all those information in your local machine itself. You don't have to check to server. Okay, clear?
So my basic question is, in this repository, the JIT, it always connect to the server, because if some people or some other resources are updating the source code, so we are getting from the local repository. So it's an integration module, whether it will always connect to the server and get updated, or how that works. That is a key question.
No, as I mentioned, you have to do two operations, push and pull. Okay, so it will not automatically sync with the server because your system is now the server. Okay, so whenever you do push, you are putting your changes in sync with the remote server. Whenever you are doing a pull, you are taking the latest changes from server into your local server.
Same file was modified by two people. Okay, the same person or the two people are using the same pull scenarios. So which one will be the latest one?
If there is any conflict, then you are whenever you are doing these operations, it will give you a warning that okay, there is a mismatch between these two versions, and you have to do a merge conflict resolution. Git has no way to understand which is the right one, right? So if there is a conflict, you have to decide which version has to be used, only in case if there is a conflict. So that is part of merging.
Okay. Is there any third person or the owner who can control this one? Because if it's a big team, some 10 people are working. So is there any who can set rights like that?
Yeah, so you have that control. So normally, whenever you are working on a feature, you'll be working on a branch, right? Before merging this branch to the main branch, in certain branching strategies, you will only have a main branch. And in certain branching strategies, you also have something called as a developer branch. So you have a main branch as well as you have a developer branch. So before either merging it to the developer branch or before merging it to the main branch, you can have a pull request process, and you can add hooks and all to say, okay, who all are the people who should be reviewing this code, who all should approve it before it gets merged to the developer or main. You have so those people, whoever is defined as the owners, will have full control on those things.
Okay, got it. Thanks a lot. Sorry for disturbing you. Okay.
No problem at all. I am always happy to.
It's some basic confusion I'm having even before to this call. Wow, it differs. Now you clarified. Thanks.
Okay, so some of the issues with JIT, or some of the objections to the use of JIT: overwriting history. If used incorrectly, it can lead to conflicts. Large files. JIT works best with the repos that are small and that do not contain large files or binaries. Consider using JIT LFS support. Learning curve. Some training and instruction will be needed initially. Existing developers from central source code management might find it a little bit difficult initially. And what is GitHub? Okay, we have talked about central source code repositories and then distributed version control. Now we are going to talk about one of the providers that provide JIT as a service. GitHub is an online provider that offers the distributed version control and source code management functionality of Git plus its own features over the internet. Over the internet is as a service, right? GitHub has a large community, automate from code to cloud. Seamless code reviews are possible. Code and documentation in one place. Coordinate better with the team members or collaborators. Manage teams. So many of these are the features of Git itself. What GitHub provides is it will provide Git as a service on internet. If you go to github.com, you can put your code there. Many open source projects use GitHub, and GitHub is now a Microsoft company. I still get questions from people asking Microsoft will prefer Azure DevOps repos or GitHub. Let us wait and see. GitHub is not the only one that provides hosted services for Git. You have Bitbucket, which is also very popular. Bitbucket is a Git-based source code repository hosting service owned by Atlassian. Atlassian, you may be knowing the company, right? You may have used a product called Jira for managing your projects. GitLab, initially it was just a source code management solution to collaborate within a team on software development. And later it evolved into an integrated solution covering the software development lifecycle and then to the whole DevOps lifecycle. With GitHub also, you can use something called as GitHub Actions. And with Azure, you have Azure DevOps pipelines. Today, you cannot live without DevOps. You need to have a pipeline. You need to follow the DevOps lifecycle. There is a question how to choose between DevOps versus Git. Okay, so you cannot choose between DevOps versus Git. You do DevOps with Git. In your DevOps pipeline, you get your code from Git or any source code repository. Shall we see some code? So you can do most of these things, whatever we learn from a GitHub perspective with Bitbucket or GitLab, etc., etc. But as I always talk about cloud, you can start with one cloud and then move to other clouds easily. I started with AWS and then moved to Azure. Similarly, start with one. So start with GitHub, which is the most popular one. And then if your work demands a Bitbucket or a GitLab, you can easily move to it. So first step or first prerequisite is going to internet, searching for GitHub and creating a GitHub account. And second step is creating a repository in your GitHub account. So for that, you have this drop down under your name, and then you can click on your repositories, and then you can click on new repository, new. And then you will get a page similar to this, where you can provide a repository name. If you have not created a repository with this name, try to create with the same name, Git101-practice. You can select whether your repository is going to be a public repository or a private repository. Public means anybody on the internet can see the repository. Private means only whoever you choose can see it. And then you can have a Readme file if you want. Readme file is a file that talks about what your project is about, kind of a description. And then you can add other files also, like gitignore. Whenever you are committing, you may not have to commit a few things which are specific to your operating system, which are specific to your IDEs, in your common repository, right? So those things, what you do not want to commit, you can mention them in this file called gitignore. And whenever you are committing your whole folder, Git will ignore those and commit only the remaining files. Then you can also add a license. Even within open source, there are lots of different licenses. Happy to discuss on it if anybody is interested. For now, you can ignore those two options. Simply create a repository with this name, Git101-practice. Select as public because all of our other team members or community members will be reviewing it. add a Readme file, and later we can make changes to that Readme file. So the initial steps are going to be very simple. There is a question, a quick overview on Git licenses, how organization can choose Git licenses. There are actually websites that help you choose licensing. So certain licenses will tell that, okay, if you are taking the code from my repository, you have to give me some kind of reference. Certain licenses may say that, okay, if you are taking a code from this repository, you have to make sure that code is also open source. So you will have a requirement. What I want to do with this project, how I want to make it shareable with others. So based on those factors, you will be able to decide on which licenses. And there are also websites that help you. You have to just choose what are your requirements, and then they will suggest which is the best license for your particular use case. So installing Git on local. So this is the second prerequisite. On Windows, you can install a software called Git for Windows from gitforwindows.org. Git Bash comes included as part of a Git for Windows package. Git Bash is an application for Microsoft Windows environments, which provides an emulation layer for Git command line experience. Bash is an acronym for Born Again Shell. On Mac, you can install Git using Homebrew as a brew install Git. You can also install Git with Mac ports. On Linux, Debian or Ubuntu, you can install Git as a sudo apt-get install Git. In Fedora, it will be sudo yum install Git. And if you are not able to do it, just do a Google search, and then you should definitely get help. So this is one of the easiest things that you can do. And how many of you who said you are working with Git heard about some kind of vulnerability recently? Explore and then share it in our WhatsApp groups. I assume all of you are attending are part of either C1, C2 or F1, F2. Otherwise, just talk to the admins and then they will move you there. As a good engineer, you will have to always be updated, because these days a lot of vulnerabilities come. There was a Log4j vulnerability a few weeks back, and many developers sat the whole weekend fixing their code. Okay, so similarly, a lot of these things will come, and then you will need to fix. So mostly, so all this fixing may be done by administrators or even DevOps engineers, not developers. In your local machines, you will do it, but on servers, it will be done by a different set of people. So it is not limited to developers, GitHub and all these things. It is actually for every software engineer. Next step is setting and viewing username and email. So this is not my real username and email. Git config. You have to, so assuming that you have installed Git and then it is there in your path, you can do git config -- global user.name and your name, git config -- global user.email, and then your email that is associated with your GitHub account. And for viewing the current configuration, you can do git config -- global user.name, git config -- global user.email. And if you have any issues, if you face any issues, just mention in your respective groups, C1, C2 or F1, F2. Many engineers there have actually completed it. So within seconds, you will be getting answers from one of them. So next step, configuring SSH, so that every time you won't have to enter your username and password. Okay, there are few steps to configure SSH. And before that, how many of you understand this concept of public and private keys, public private key encryption, public private key combination, and all those terms? If there are interested people, I can have it as part of our systems design discussion. You can use these simple commands in your Mac, Linux, or with Git for Windows. Just type SSH keygen -o in Mac, Linux, or Git for Windows. And then it will generate a public key and private key combination. Let me quickly tell you about these public and private key combinations. Whenever you have a public private key combination, you share your public key with others. Whenever you are encrypting something using your private key and sending it, and then, so what is this encryption? Okay, encryption is a way to make sure that nobody else will read your messages. When you encrypt a message, it will change your plain text into a cipher text, and when you decrypt a message, you change the cipher text back to plain text, and this is done using a key. There are two kinds of encryption. In symmetric encryption, you use the same key for both encrypting and decrypting, and in asymmetric encryption, you use either public or private key for encryption and use the other one for decryption. So if you encrypt using a private key, you decrypt using the corresponding public key, and if you encrypt using a public key, you decrypt using the corresponding private key. So normally you keep your private key with you, you give your public key to other people. When they decrypt it successfully using your public key, they can be sure that it is sent by you. In simple terms, private key is with you. So if you encrypted something with your private key and somebody is able to decrypt it using your public key, that means this message was sent by you. Okay, we will discuss it in very much detail in our systems design and discussion. For now, you have to just make sure you find your public key. It will be usually in a file id_rsa.pub, and then copy the whole contents from that file. Last time when people did the lab, they did a mistake. Whenever you generate it, you will see a fingerprint of this generated file in your command line. So some people copy pasted that fingerprint and then pasted it into your GitHub account. That will not work. So what you have to do is you have to go to this file that was generated, open it, copy the whole contents, come to your server and go to this SSH and GPG keys tab, click on new SSH key and then paste the whole thing there. In GitHub, you can go to settings and then you can do all those things. Whenever you make a request from your command line to GitHub, then GitHub will understand that, okay, this request is coming from this person. So let me not ask him for a password or additional things. Let me allow him to commit code or check out code, whatever he is allowed to do. And next step, you have created a repository in your server. You have configured SSH. Now, every time you don't have to give any username or password. Your GitHub account will understand that, okay, this request is coming from this person. And then, as we mentioned, when we discussed about distributed source control systems, you clone your repository to your local system. How do you clone? So first you go into your repository and then under this code option, you will get few options, few tabs. You can use HTTPS, you can use SSH, you can use GitHub CLI, but here we are using SSH, which is kind of the most preferred for me. Okay, so we have configured SSH, so we will copy paste this SSH based clone URL, and from your local machine, it would be good to create a folder for all of your GitHub activities, and inside that folder, run this command git clone and whatever URL you copy pasted. It will create a new folder and then it will take whatever is there in your server into your local server. So you have created a GitHub account. You have created a repository in your GitHub account, a public repository. You have configured SSH. You have cloned your remote repository. If you have further doubts, even after the session, you always have the option to ask doubts in our WhatsApp group. So this is just a snapshot of what I did. Git clone, you paste your clone URL And then you'll get a message that cloning into Git 101 practice folder and some messages. In my remote repository, I had only one file, readme.md. If you are following along this lab, then you will also have only this one readme.md file, assuming you checked that option to create it while you created your repository. If you are watching in YouTube or any platforms at a later point of time, then you can pause the video now, do the lab, and then you can continue. If you are part of C1 or C2 groups, just message in the group that I'm going to do the lab, then use the groups 24/7 Zoom meeting. Both of those groups has a 24/7 Zoom meeting that you can use to discuss and do labs together with other Azure engineers. So that is a premium feature of C1 and C2 groups. You have a 24/7 Zoom meeting available for you to discuss anything and everything or take sessions to the community. To understand the basic workflow, first, you create a new file or make changes to an existing file. So assuming that we already got the code into your local machine, or the repository, cloned the repository into your local machine, what are the operations that you generally do after that? Either you create a new file, or you make changes to an existing file, or maybe delete a file, but that will also come under modification. So in general, you create a new file or make changes to an existing file, including a deletion. This file, this modified file or a created file is now in an unstaged state. So these states are important. So now they are unstaged. When a file is unstaged and you say commit, it will not be committed. Only staged files are committed to Git. So whenever you are ready to commit a file, you can say that, okay, now stage this file. How will you stage the file? You use git add file name command. So you use git add file name command. This will stage the file for commit. As I mentioned, only staged files are committed by the commit command. Then commit the file using git commit command, and commit permanently saves the file in your local Git repo. Create or modify file in your operating system specific way. Whenever you create or modify a file within a GitHub repository folder, it will immediately become a unstaged file. And then you can use a git add file name to make it as a staged file. And after that, you can use the git commit command to actually save it permanently to your Git repo. So now tell me one thing, after I do these three steps, can another developer from my team see these changes? Yes or no? Okay, so the answer is no. Why? Because we are using Git. Git is a distributed version control system, and I have committed it into my local server. And I have to use one more command called push to send all changes from my local server into remote server. So in WhatsApp groups today, all of your groups, you try to get a pair developer from your group, and then try to do these exercises together. So when you commit, the other person try to get it using a pull and all those things. Okay, so now some useful commands continuing. So we did a clone, and then we can make changes. How do you make changes? You can, in Windows, you can just double click and make changes. And in Linux or Mac, you have a VI editor. So you say VI readme.md, and then it will open. And then if you are already using Mac or Linux, you will definitely know VI, or you can use any editing tool that you are comfortable. Make changes to the readme file, and then save it, and then do a git status. So git status will show whether a file is staged or unstaged. I told you about the staged, unstaged, commit, etc., right? So these are how it is done. So when you say git status, it will tell your branch is up to date with the origin.main. Origin.main is the name I have given to my remote repository. Changes not staged for commit, modified readme.md. So it says that I have modified a file, but it is not yet staged for commit. Then what do? Then I do git add readme.md. Then I do git status again. It will tell, okay, changes to be committed. And then now it is in green. So now it is ready for commit, or it is staged. And after that, I can do my commit, git commit -m, my first commit. Now what will happen? It will commit or save to my local server. Finally, it will give me a message, your branch is ahead of origin/main. You asked me about server and local, right? It will remind me. It will remind me your branch is ahead of origin/main by one commit. Use git push to publish your local commits. When I do git push, all these commits will go to server. Since I have committed all staged files, it will say nothing more to commit, working tree clean. So is it clear now? All those things I mentioned about the staging, committing, and pushing. And then finally, what do? You do git push origin main, and it will push my changes from my local machine to the remote machine. Now other developers will be able to see my changes. So once you do this git push origin main, I want all of you to share your repository in our WhatsApp groups so that others can verify it. Even I can verify. All of these things will be 100% clear only with the practice. And if you want to know what is your remote configuration, what is your remote server, you can just use this command git remote -v. It will tell you I have two origins, one for fetch and one for push. Fetch means whenever I am taking code, it is taking from that. Push means whenever I are pushing, it is going to this URL. And after that, you can go to your server and then you can verify things. Okay, after this stage, just share the URL like this. Mine is github.com/hearten/git101 practice. So similarly, your link, you can copy paste and share it in our WhatsApp group. And for people doing either Forum CA or Forum CA 45-day crash course, it is mandatory for them to share in their respective groups. As I mentioned, you can add the files that needs to be ignored by Git in a file called .gitignore, and Git will not stage those files. Useful especially when you use a git add dot. So until now, how did we add the file? We said git add file name directly, but you can also say git add dot so that it will add all the files that are ready to be added. So all the files that are not ignored. So when you say git add dot, it will add all the files in that folder, but excluding those ones that are part of this file called .gitignore. Where do you use this file? Sometimes for ID specific files or operating system specific files, you use this because you don't want to commit and then make it available for others to see. And some more useful comments. These are optional for you to try out at this point, but I strongly encourage you to do these things also and then share if you face any issues in our groups. VI readme is how you edit, then you add files. Since we have only one file, it will be added. Then when you say git status, it will say, okay, modified. So until this modified part we already saw, right? Until this modified part we already saw. What if I want to unstage that file? Then you can say git reset head readme.md. So it will unstage that file. So it will again become red. So if now after becoming red, if you try to commit, it will not commit it. You have to again add it and then you have to commit it. Whenever you commit, you also give a message. So for example, git commit -m and then give some message, some meaningful message. Because when somebody else see your commits, then they will understand what is this commit about. In real world, in real projects, most of our tasks will be managed in some kind of task repository, right? So like Jira. So some people use Jira, some people use Azure bots. Irrespective of what tool you use, you'll have some kind of task ID or bug ID or something will be there. So generally you mention those things in your commit message. And imagine you provided a wrong message. You can use this command, the git commit --amend to change it. Okay, so change it and then save it. In case if you want to change your remote URL, then you can use this command, git remote set URL origin, and then provide the URL like this one. And then you can verify it using git remote -v. And you can also check logs. You can say git log, and it will provide all the recent commits in a chronological order. And if you need only the messages, commit messages without all these things that you see in the left, what you can do? You can do git log --, one line, and then it will show this clean message. So sometimes you'll have a lot of commits. You just want to understand, okay, what is the order of commits? And then this, so left side, you have the complete commit hash, and then this is a smaller hash. Both of them will work whenever you want to go back in time. So you can play around with these things. Sometimes it may lead you into the multiverse madness, but still it will be fun. And doing it along with a community of engineers is going to be extra fun. So whenever you are going to do this lab, just mention in WhatsApp and then try to do it together using your group's dedicated Zoom. Or if your group does not have a dedicated Zoom, just do it on your own and then share updates in the group. Okay, be active and then learn together. So ours is one of the most energetic communities that are there around. Sometimes if your push does not work, you can do a force push. This is one of the negatives that we saw earlier. So it can rewrite history. So do it with extreme caution. Get changes from remote to local. You can use a git pull origin main. So this is how you make sure your repository is in sync with other people's changes. Best practice is always do a push and pull regularly. And also before doing a push, do a pull. Quick note on git init. The git init command is one way to start a new project with git in local. So there are two ways in which you can create a project. What was the way we did until now? We created a project on the server, and then we took that project from server to local. We can also do the opposite. We can create a project on local and then push that changes to server. So here your git init command comes to help. So whenever you are creating in your local and then pushing to server, then you can use git init command. We can work with all git commands the same way in local, unless it is fetching or pushing to a local to a remote repository. To connect our, so once you create this local repository and then make all your changes, then you have to push it to server. But when you cloned, your local already knows that I was cloned from this server. So this is my remote. But now you created directly in your local. So your local does not know, right? So what you can do, you can use git remote add origin and then the remote repo URL. On a quick note, this origin is not a command. You can give any name, but origin is the most common convention. To start a repository, We can use either git init or git clone, but not both. Git init when you start a repository local and plan to push to server later. Git clone when you already have a repo on server and then you take it. As a practice, most of the cases we create it on server and then clone, but there is always this option to create it first on local and then push it to a server. So getting started with GitHub pages. What are these GitHub pages? Okay, so if you go to heartin.github.io in your browser, you can see this. You can read all about me, my books, experience, education skills, interests, awards, contract, etc., etc. Okay, so you can also easily create a similar one. And if you go to pages.github.com, you can see an intro video that explains most of these things in a very beautiful way. And how did I create this page? So this is your second assignment. Create a page for your own and share that link in our group. How do you create? So first, you go to your GitHub account and create a public repository with the name as follows. So if your account name is my account name is Hartin, right? So my GitHub pages link will be hartin.github.io. So I'll have to create my repository also with the same name. So if your name is Abhi, for example, your username is Abhi, then it will be abhi.github.io. Okay, so first step is creating a repository, and then you go into your settings and then check. So it will go into pages and it will check. It will tell, okay, your site is published. And whatever website I used, you can also use. You can go to, or you can create, if you are familiar with HTML, JavaScript, CSS, you can create your own website, or you can go to this link, startbootstrap.com/theme/resume, and then you can download this file and then use some tool to just edit the text and then upload it. Okay, and then commit and push website changes to this repository in GitHub, just like what we learned. And then go to settings when it is published, go to website. Very straightforward, right? So it's very easy. And best part is it is free. You can host your websites free with GitHub. I'll just list out what are planned for future sessions. Apart from coding and website hosting, any other services use it? I mentioned, right? So any document you can save it in your GitHub, and then share with others. Whenever you want to share something with others, whenever you want to keep track of the versions, keep track of the changes, you can use Git or GitHub. DevOps engineers use it for maintaining their infrastructure as a code scripts. It is not just for developers. There is this concept of monorepos versus multi-repos. Monorepos refer to keeping all source code in a single repository. It is easy to fix bugs. In other projects, can focus on only one repo, can become difficult to manage as projects increase. Multi-repos refer to having different repos for each project. Projects have flexibility to work in their areas however they want. Anything not developed within a repo has to be consumed as if it was a third-party library. Fixing bugs in other repos will need more effort and coordination. You can think about it and tell me which is better for microservices-based architecture. Changelog, it is a file with a list of changes made to the project, usually in a date order. Typically, it will have added, modified, improved, deleted features in each major and minor release version. Some teams may post changelogs as blog posts, but others may create a changelog.md markdown file in a GitHub repository. And some tools you can refer. Gitlog command to auto-generate from a script, the Git changelog tool based on Python, the GitHub changelog generator based on Jump. So some tools to explore. In future sessions, we will definitely look into it. And then Git hooks. There is a thank you, sir, for this wonderful session. Session is not yet over. Please don't run away. So Git hooks. a mechanism that allows a code to be run before or after certain Git lifecycle events. Example, check if a commit messages follow recommended structure. I told you, right? Commit messages in some companies mandate that, okay, you have to use a bug ID, valid bug ID, or valid task ID from whatever task management you are using, whether it is Jira or whether it is Azure DevOps boards. So hooks can be any executable code, including a shell, a PowerShell, Python, or other scripts, or even a binary executable. The hooks must be stored in the .git/hooks folder in the repo root and must be named to match the related events. Example, pre-commit, commit message, post-commit, pre-rebase, etc. So 2 questions you can explore. What is the commenting practices followed in your teams? Do you have any such restrictions imposed? Do you enforce it using Git hooks? And if you can share it with the group, it will be extremely valuable for others. Because I always tell the group, even yesterday, there was a discussion around it. People say, you learn from your mistakes and experiences. But according to me, there is not enough time for any of us to learn from only our experiences and only our mistakes. So the community is your place to go for learning from others' experiences and others' mistakes. That is the beauty of a community like Cloudrix. Question 2, if your team uses Git hooks, what are the things that you have implemented using it? Okay, something for people who are already using to explore. And then we will also discuss in future sessions difference between fetch and pull. In summary, pull code is downloaded and applied to a local code. Fetch code is downloaded but not yet applied. Purging repositories, common situations to reduce the size of repository by removing storage, removing a large file that was accidentally uploaded, removing a sensitive file that shouldn't have been uploaded. So there are few approaches we can discuss and then find out which is better. First one is the filter branch. So standard built-in Git method for removing files by rewriting history. The SHA hashes for the commits will also change. So Git filter branch, index filter, and then you can use this command. And also you can use a tool such as a BFG repo cleaner. It's an open source tool for deleting or fixing content in repository. It is easier to use compared to the built-in filter branch command. You just say BFG delete files file name. And the to-do exercise for the extremely active people, explore and try both approaches to delete a demo password file you uploaded by mistake. You can make a mistake by choice, and then also added under future sessions. Again, this is not it. So these are my plans for future sessions. If you need any more topics, please feel free to let me know by commenting within the YouTube channel or by letting me know in the WhatsApp groups. So Git branching, forking, and branching strategies in depth. Explore pull requests, merge versus rebase, fetch versus pull. A lot of things are there further to be explored. Explore and implement the CI with GitHub Actions, a very interesting topic. Hard versus soft reset in depth. Also reset versus checkout for going back in time. Explore and implement Git hooks. Stashing code. If you want to keep your code aside, how do you do it? Purging repositories, tagging, especially for release management, aliases. We have just learned the essentials in this particular session. And in our group, we will continue learning. I am assuming all of you are already part of our WhatsApp groups. If not, you please join. I'll try to include the link to join the S1 group, which is an open group that anybody first joins. But in S1, you will not have any permission to post anything. The reason is because we don't know what kind of people are joining. And after that, you have to introduce yourself to an admin and tell that, okay, I'm a real person. This is my GitHub account, or this is my LinkedIn profile. And you can join any of the actual groups. Because we had very bad experiences of people coming in and sharing whatever they wanted. So that is why in S1 group, you will not have sharing permissions. But in all other groups, free or contributors group, everywhere you will have all permissions. Finally, best practices for source control. Always make small changes at a time. Don't commit personal files. Update often and write before pushing to avoid merge conflicts. Verify your code change before pushing it to a repository. Ensure it complies and tests, or ensure it. So verify your code before pushing, and then ensure it compiles and tests are passing. Pay close attention to commit messages, as this will tell you why a change was made. Link code changes to work items, something I already told you, and which is very rigorously followed in most of the real projects. Finally, be a team player and follow agreed conventions and workflows. So there will be different possible workflows that you can implement, especially with respect to branching strategies and all. There is no one way to do it. So your team will decide on certain things, certain conventions, certain workflows. Follow it as per your team. Thank you. Ask questions in our WhatsApp groups. And if you are doing the lab, do it together along with other community members. It is super fun. Every day in C1 and C2, people join together and do labs together. And especially in C1, almost every day you get to hear some knowledge sharing session from some expert based on their real world experience. If we can be part of groups such as C1 or the contributors group, it will be extremely good. All you have to do is just share knowledge once in a month and gain knowledge from all other people, or just help the community with a small contribution to run our ad-free community portal, which is cloudrix.com. Cloudrix.com is very similar to Facebook. The difference is that Facebook makes money through ads and provides you with all kinds of distractions. And cloudrix.com, everybody contributes a little bit, and then the community uses that to manage a ad-free Facebook-like portal. Before I wind up, I just want to ask one question. Whether you are watching it live or whether you are watching it later, have you learned at least one new thing today? Do you think the session was useful to you? That is the only motivation I need to take more classes for you. So do share your feedback now and also later when it is published. Anyway, thank you for all the kind and wonderful words. Okay, this will definitely encourage me to take more sessions to the community. Okay, once again, bye bye for now, and see you all in next session. Until then, be safe and continue to practice something hands-on daily with our Cloudrix community members. And whenever you have some useful information, do share it with the group. Okay, bye bye for now, and